Hi, my name is Pavaani Thevathas. My metric number is 13DEM 19F1043. So, self-excited. Self-excited DC generator is a device in which the current to the field winding is supplied by the generator itself. In self-excited DC generator, the field coils may be connected in parallel with the armature in the series, or it may be connected partly in series and partly in parallel with the armature windings. Next one. So this is self-excited series. A series wound generator, the field coils are connected in series with the armature winding. The series field winding carries the armature current. So this is the circuit diagram, which is series wound generator, and it's arranged in series. So the next one is, so this is the equation. I equals to ISC equals to IA. I means current, ISC means series current, IA means armature current. And the second one is negative VT plus IA times RSC plus IA times RA plus EB equals to 0. So VT is voltage applied across the motor terminal, and IA means armature current, as we know. So RSE means series resistance, and RA means armature resistance. EB means back EMF. So the third equation is VT equals to EB plus IA bracket RA plus RSC. So these are the equation of series wound generator. So there are some advantages and disadvantages of series generator. So let me see the advantages. First one is best used for driving heavy loads DC, operate at low speed, high starting torque, construction is simple, and the last one, less maintenance. And the disadvantages are never allowed to run in unloaded condition, and speed regulation is poor. So let's go to question section. So a DC series motor takes 60 ampere at 240 voltage. Armature and field resistance are 0.2 ohm and 0.1 ohm respectively. So find the back EMF. Let's find out the answer. So in the question they gave I equals to 60 ampere, and ISE means it's armature current. The second one, VT 24 voltage, RA 0.2 ohm, and RSE equals to 0.1 ohm. So let's write down the formula first. Negative VT plus ISE RSE plus IERA plus EB equals to 0. EB equals to VT minus ISE RSE minus IARA. So the VT is 240, ISE 60, the RSE 0.1 minus IA is 60, the RA is 0.2. So let's calculate that. 240 40 minus 60, 0.1 minus 60, 0.2, and the answer is 222p. So this is the final answer that we get. That's all. Thank you.
My name is THARSHINIE and my metric number is 13DEM19F1017. I'm going to explain about self-excited shunt DC motor. A shunt DC motor, or more specifically, shunt self-excited DC motor, the field windings are exposed to the entire terminal voltage as they are connected in parallel to the armature winding. So here is the circuit of shunt DC motor. This circuit is arranged in a parallel circuit. This circuit actually remains VT is equal to V shunt is equal to VA plus VB, EB. There are three equations for shunt DC motor. First of all, it's IL is equal to ISH plus IA, which means total line current is equal to shunt current plus armature current. And the second one is VT is equal to VSH times ISH, which means voltage applied across is equal to shunt voltage times by shunt current. And the third one is VT is equal to EB plus IARA. It means voltage applied across is equal to back EMF plus armature current times by armature resistance. There are some advantages and disadvantages in self-excited shunt DC motor. The advantages are excellent speed regulation and constant speed motor used in lathe machines, mill machines, conveyors. And the disadvantage are not suitable for large starting torque, and motor gets damaged due to large centrifugal force. It field winding gets disconnected during normal operation. I have an example question to do. I'll explain how to do that later. First of all, we read the question first. A DC shunt motor 200 voltage has an armature resistance of 0.5 ohm and a drop voltage of 4V and armature current of 20 A. We want to find the back EMF and the armature current if back EMF is 175 voltage. Okay, first of all, we write down the formula to find back EMF. Okay, VT is equal to IA RA plus EB. Insert the value given up there. 200 is equal to 20 times by 0.5 plus EB. Now we are going to find the EB. Okay, now calculate this. 20 times 0.5 is absolutely 10 plus EB. Shift this 10 to the left. 200 minus 10 is equal to EB. So the value of EB is 200 minus 10 is 190, and the unit for back EMF is voltage. Now we are going to find the armature current if back EMF is 175 voltage. The formula we are going to use is same as the formula we used for question A. The value of VT is 196 is equal to IA, because IA is what we want to find. RA is 0.5 plus EB is 175. Okay, now 196 minus by 175 equal to IA times by 0.5. 196 minus 175 is equal to 21, equal to IA times by 0.5. Now we are going to shift this IA to the left side and this 21 to the right side. It will become 0.5 divided by 21. The answer of armature current is 42 and the unit for armature current is A.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Cik SYAKIRAH binti Cik Muhammad. Nombor matrik 13 DEM 19F1009. Compound wound generator. In a compound wound generator, there are two sets of the field winding on each pole. One of them is connected in series having few turns of thick wire, and the other is connected in parallel having many turns of fine wire with the armature windings. In other words, the generator which has both shunt and series fields is called the compound wound generators. If the magnetic flux produced by the series winding exceeds the flux produced by the shunt winding, then the machine is said to be cumulative compounded. If the series field flux opposes the shunt field flux, then the machine is called the differentially compounded. It is connected in two ways. One is a long shunt compound generator, and another is a short shunt compound generator. If the shunt field is connected in parallel with the armature alone, then the machine is called the short compound generator. In long shunt compound generator, the shunt field is connected in series with the armature. The two types of generators are discussed below in details. In a short shunt compound wound generator, the shunt field winding is connected in parallel with the armature winding only. The connection diagram of a short shunt wound generator is shown below. This is an equation for short shunt compound wound generator. Self-excited DC motor compound in advantage is quick start and stop of the motor can do. Reversing and acceleration of the motor can do fast. For disadvantage, operation and maintenance costs of DC motors are expensive. DC motors are unable to operate in hazard situation where spark occurs at the brush of the motor. In generally, every DC motor using brushes, so the lifetime of such motors is less compared with AC motors. For applications, compound motors are widely used in applications such as elevators, conveyor belts, air compressors, and punches. Last is can use for variable speed domestic appliances.
Hai, Assalamualaikum. Nama saya FATIN ALIA binti Muhammad AZAM, bernombor matrik 13DEM 19F1047. Long shunt compound wound generator. In a long shunt wound generator, the shunt field winding is parallel with both armature and series field winding. The connection diagram of the long shunt wound generator is shown below. For equation, V equals to EG minus IA RA plus RSE minus 2VB. Power developed equals to EG IA, power output VIR.